Gardner, Massachusetts is home to 21,500 people, a regional hospital, and a community college. Its energy profile and the specific pressures it faces represents a case study for thousands of municipalities across the United States. The region is approaching a significant energy deficit. According to ISO New England, local electric demand is projected to rise 44% by 2045. While wind and solar capacity are growing, Gardner requires a carbon-free baseload, a source that stays online during severe winter storms, when energy peaks in this part of the country can double. To hit those zero-emission targets without risking a blackout during a sub-zero peak, the town is looking for a weatherproof power source that can be sited directly within its borders. State leadership has signaled a path forward. Recently, the governors of all 6 New England states signed a joint statement committing their energy agencies to explore advanced nuclear power to meet this surging demand. This commitment does not mean Gardner is going to build a legacy nuclear facility. Traditional plants require sprawling exclusion zones and massive cooling towers that are physically impossible to place next to a historic downtown. Instead, the goal is atomic energy out of a box, a new class of small modular reactors and microreactors. Let's look at Gardner's energy math. At a ratio of 1 megawatt per 750 homes, the town's residential needs, combined with its hospital and college, require a capacity of between 20 and 60 megawatts. Traditional legacy reactors produce upwards of 1,000 megawatts. For a single town, that scale of infrastructure is a massive mismatch. Advanced reactors scale down to local needs, from a 60-megawatt SMR to a truck-sized microreactor. Their physical footprint shrinks accordingly. Traditional plants need 500 acres. SMRs require 35, and a microreactor sits on a football field. Miniaturization allows a power plant to integrate into Gardner's municipal grid without dominating the local landscape or requiring major new real estate. These reactors are modular, meaning they are fully assembled in off-site factories and shipped by truck or rail. This process avoids the decades of complex on-site construction that slowed down previous nuclear projects. Beyond their size, the primary breakthrough allowing these reactors to be placed near populations is a concept called passive safety. Older designs require active mechanical pumps to cool the core. Passive safety systems rely on gravity and natural convection to circulate coolant. If power is lost or a sensor fails, the physics of the system automatically cools the reactor without human intervention. Because the risk of a meltdown is mitigated by the laws of physics, designers are proposing that these reactors be situated right next to community colleges or industrial parks. This technology is currently moving from testing into the field. The U.S. military is already evaluating microreactors through Project Pele, with an eye toward deployment at domestic bases by 2028. Commercial adoption is right behind the military. The first utility-scale SMRs are slated for construction at existing nuclear sites in Michigan and Texas by 2030. Based on these industrial test cases, a municipal grid like Gardner could realistically flip the switch on its first small reactor in the early to mid-2030s. To reach that 2035 goal, the industry has to clear 3 hurdles. First is the cost. Capital investment must fall below $3 million per megawatt to compete with natural gas and renewables. Then there is the massive regulatory bottleneck. The Nuclear Regulatory Commission is currently adapting licensing rules originally written for massive gigawatt-scale plants to fit these small factory modules. And finally, the question of radioactive waste remains. While these reactors use fuel more efficiently, the United States still lacks a permanent national site for long-term disposal. The engineering behind these reactors is robust, but the economics and federal bureaucracy could still stall Gardner's proposed timeline. Even if the costs drop, the Gardner City Council faces a historical barrier. Public perception of nuclear power is still shaped by legacy meltdowns like Chernobyl. Overcoming that stigma requires a new architectural approach. Researchers are proposing that SMR sites be designed as integrated civic spaces, visitor centers, public parks, or art installations, rather than fenced-off industrial compounds. Studies suggest that this emphasis on transparency and community integration is a key strategy for building the social trust necessary for a town to adopt local nuclear power. If Gardner navigates these economic and social hurdles by 2035, the town could provide a model for a future where nuclear energy is no longer a distant megaproject, but a quiet, integrated layer of local infrastructure.